All right, let's talk about something we do every single day. Use the internet. We're going to pull back the curtain and trace that hidden journey that happens every time you click a link or type in a web address. We're going to see how it all really works from start to finish. So let's dive right in.
I mean, have you ever really stopped to think about it? You click on something and bam, a website from maybe halfway across the planet just appears on your screen. It feels like total magic, right? Well, it's not magic, but it is an incredibly fast and complex little journey. And today, we're going to follow it every single step of the way.
So, first things first, let's make sure we're on the same page with our terms. When we're talking about sites like your email or Amazon or any social media, we're not just talking about simple pages. We're talking about web applications. Think of them as powerful pieces of software that just happen to live on a computer somewhere else, waiting for you and your browser to interact with them.
At the very heart of how the web works is a really simple concept. It's all just a conversation, a quick back and forth between your computer and the computer where the website lives. So let's meet the two main characters in this story.
Okay, on one side, you have the client. For all of us, that's our web browser, Chrome, Safari, whatever you use. Its job is pretty simple. Ask for stuff, and then show us what it gets back. On the other side is the server. This is a big, powerful computer that's holding all the website's files, its data, all the logic. It just sits there and listens for requests, and when it gets one, it processes it and sends a response back. It's kind of like a librarian who goes and finds the exact book you asked for.
Now, for any conversation to actually work, both people need to speak the same language. On the web, that language is called HTTP, the Hypertext Transfer Protocol. You can just think of it as the set of rules for the road that makes sure every single request from the client and every response from the server are perfectly understood.
So, when you decide you want to go to a website, your browser, our client, is the one that starts the conversation. It carefully puts together a message, which we call an HTTP request. Let's actually take a peek at what that message looks like.
Okay, I know, this looks a little technical and codey, but don't worry. The best way to think about this is not as code, but as a very specific, very structured letter that your browser is writing to the server. And this letter has everything this server needs to know to send the right thing back. Let's break down the most important parts.
This first line, this is the headline. It's the most critical part of the whole message. It starts with get, which is the action word, the verb. It tells the server, I want to retrieve something. The little slash just means you want the main homepage. And HTTP/1.1 is just the version of the language we're using. So in plain English, this whole line is just saying, hey there, can I please get your main homepage? The next line, the host header, is basically the address on the envelope. See, a single server computer can host hundreds, even thousands of different websites, all on the same IP address. This line tells the server exactly which one you're looking for. Without it, the server would have no idea which of its many sites to send you.
And then there's this line, the user agent. This is basically your browser introducing itself. It's saying, hi, I'm a Mozilla browser, and I'm running on this kind of computer. And this is actually super useful because it lets the server send back a version of the website that's perfectly optimized for your specific browser, or even your phone. Pretty clever, right?
So imagine this server just sitting there all day long, getting millions of these requests from all over the world. The thing is, it has to treat every single one of them as a potential threat. Because while your browser sends a nice, polite, friendly letter, other people can craft malicious requests that are specifically designed to break things and cause harm.
Now, before we get into that, it's really important to understand this one distinction. A threat is the who or the what that could cause harm, like a hacker trying to get in. The risk is the chance that the threat actually succeeds and the damage it could cause. A locked door doesn't eliminate the threat of a burglar, but it seriously reduces the risk of them getting inside. Web applications are facing this constant barrage of threats. For instance, an attacker could use something called SQL injection. That's where they craft a very special request that tries to trick the website's database into just spitting out all of its private user data. Or they could try cross-site scripting, where they inject malicious code into a web page so that when other people visit it, that code runs in their browsers and steals their info. These are just a couple of the ways attackers can turn a simple HTTP request into a weapon. Okay, so let's get back to our friendly request. We'll assume ours was a good one. The server has processed it, and now it's ready to send a reply. And this return trip, the HTTP response, has its own special structure, a lot like the request we just looked at. Yup,
Just like the request, the server's response starts with some important information called headers, and then it sends the actual web page content. This info at the top basically tells your browser what's coming and how to handle it.
And again, that first line is key. This is where we find the status code. And a code of 200 OK is the one you always want to see. It's the universal sign for success on the web. It means I found exactly what you asked for, and here you go. Of course, you're probably way more familiar with another status code, 404. This is what the server sends back when it looks for the page you requested and it's just not there. It's the server's polite way of saying, sorry, I've got nothing. It's the same system, just a different, less happy message. So we've seen the request and the response. It's a pretty efficient little conversation. But this whole thing raises a really, really important question. With all this information flying back and forth, is any of it private? Is anyone listening in?
And the answer, by default, is a big fat no. Standard HTTP is basically the equivalent of sending a postcard through the mail. Anybody who happens to grab it along the way, say at a public Wi-Fi hotspot, can read the entire thing, every single word, including any passwords or credit card numbers you might have sent. This is where HTTPS comes in to save the day. That little S at the end stands for secure. And what it does is it wraps that entire HTTP conversation in a protective layer of encryption. It turns that readable postcard into a sealed, armored envelope. The message inside is totally scrambled, and only the person it's meant for, the server, has the key to unscramble and read it. So why is this such a huge deal? Well, first, you've got encryption. That's what protects your sensitive data from anybody trying to eavesdrop. Second, it makes sure that nobody can mess with the website's content on its way to you. And third, it authenticates the server, which is how your browser proves you're connected to the real Google.com and not some imposter site. But, and this is a really big but, it's so vital to understand this one last thing. HTTPS is absolutely essential. It secures the road between you and the server, but, as this quote points out, it doesn't secure the destination. You can have a perfectly encrypted, private conversation that still delivers a malicious message to a vulnerable application. Securing that conversation is just the first step. The real battle for security happens inside the application itself.